Hi dear students, welcome to the another section of Fun Short series. Today I am going to take alternating currents. Move on to the first topic, that is nothing but AC generator. We know that it is a device that converts mechanical energy to electrical energy. It works on the principle of electromagnetic induction. That is, when a coil that is rotated inside a magnetic field, an EMF is produced in it. So what are the major parts of a generator? Major parts of a generator are armature, field magnet, slip ring and graphite brushes. So here strong field magnet. It is a permanent magnet or a electromagnet whose poles are cylindrical in shape. That is used as field magnet. The armature coil rotates between the pole pieces of the field magnet and slip rings. The two ends of the armature coil are connected with the two brass slip rings. These rings are rotates along with the armature coil, and also there are two carbon brushes. They are pressed against the slip ring. So move on to the internal diagram of the generator. Now this is the field magnet. Field magnet. These are the pole pieces of the field magnet. Now the armature coil that is placed in between the pole pieces of the field magnet. Now the plane of the coil is perpendicular to the magnetic field. Now this is the area vector that is normal to the surface. Now the coil that is rotates in anti-clockwise direction with an angular velocity omega. Now the angle between the magnetic field and the normal drawn from the plane of the coil, that is theta. Now the coil rotates, what happens? Theta changes. Now the flux linked with the coil. Now there are n turns. Flux phi is equal to NAB cos theta. Now the coil rotates with an angular velocity omega. After t seconds, we know that theta is equal to omega t. So phi is equal to NAB cos omega t is the flux linked with the coil after t seconds. Okay, so what happened here? The coil rotates, theta changes, omega t changes, so flux phi also changes. Flux change, we know that here flux changes and EMF is induced according to Faraday's laws of electromagnetic induction. So the induced EMF is equal to what? Minus d phi by dt is the induced EMF. So E is equal to minus d phi by dt. So E is equal to minus d phi by dt minus d by dt of NAB cos omega t. While taking the derivative, you get E is equal to NAB omega sin omega t, that is equal to E naught sin omega t. So here E is equal to NAB omega sin omega t is known as instantaneous value of induced EMF, and E naught is equal to NAB omega. This is E naught is equal to NAB omega, that is known as maximum or peak value of induced EMF. So here NAB omega is the maximum value of induced EMF, is instantaneous value. So how to find the instantaneous current in the circuit? Instantaneous current in the circuit, I is equal to induced EMF, that is instantaneous EMF divided by resistance, is equal to NAB omega sin omega t divided by R. So I is equal to I naught sin omega t, that is known as the instantaneous current in the circuit. What is I naught? I naught is equal to peak value of induced current or the maximum value of induced current. So I naught is equal to NAB omega divided by R is the peak value or the maximum value of induced current. So here I is equal to I naught sin omega t, induced EMF is equal to E naught sin omega t. Then how to find the magnitude of that EMF or current at each and every instant? Here first putting omega t is equal to 0 degree. Omega t equal to 0 degree means that the plane of the coil is perpendicular to the magnetic field. Plane of the coil is perpendicular to the magnetic field. Here is equal to 0. Now the omega t is equal to 90 degree. Omega t is equal to 90 degree means plane of the coil is parallel to the magnetic field. Valence of the coil is parallel to the magnetic field. Then substituting E is equal to E naught. By substituting the proper values, then we get the property of that induced EMF like this. Now this is the variation of induced EMF as well as the induced current. What happens? So when a coil that is rotated inside the magnetic field, its magnitude and the direction of EMF that changes continuously, that EMF is known as alternating EMF. Current thus produced is known as alternating current, AC current. Okay, now these are the maximum values, peak value E naught. Now this is minus E naught. Now this is corresponding to 2 pi. This one is pi. Here it is pi by 2. This one is 3 pi by 2. So now this is the corresponding variation of the current. This is I naught. This one is minus I naught. These are the corresponding current. Current varyumbol konja amplitude kammiyaavum because current is equal to that EMF divided by resistance. So when a coil that is rotated inside a magnetic field and EMF is induced, the direction and magnitude of this induced EMF and also current changes continuously. So that current is known as alternating current. How alternating current that is produced when a coil that is rotated inside the magnetic field. Okay, now so here E is equal to E naught sin omega t, I equal to I naught sin omega t. Each and every instant the magnitude and direction continuously changes. So how to represent that AC? Okay, so suppose in case of a DC voltage 20 volt, that means it is a DC voltage, 20 volt DC. That means the 20 voltage remains constant. For AC, now the AC voltage is 20 volt. We cannot return as AC voltage is equal to 20 volt because AC continuously changes. So AC voltage that is represented as, suppose the current is 20 sin 50 pi t. This is the representation of AC current. Now 20 is the peak value. Each and every instant that value changes. So what is the value of AC? 20 sin 50 pi t. Okay, we cannot return as 20 volt like this. So how to represent the AC? So here the AC, its values at each and every instant its value changes. So value continues to change. To represent that quantity, you have to consider average value. Average find pananam. Okay, so average value of AC. So average value of AC over a complete cycle. Okay, so this is the full cycle. Complete cycle means that constitute a one time period, that is the complete cycle. Okay, so average value of AC over a one complete cycle, this is the representation of average value f of t is equal to 1 by t integral 0 to t f of t dt. That is equation to find the average value of AC. Here you have to find the average value of AC. Here average value of AC E naught sin omega t is equal to 1 by t integral 0 to t E naught sin omega t dt is the average value of AC. While integrating, you get that is equal to 0. So the average value of AC over a complete cycle is equal to 0. From this graph, we can directly write equal positive and equal negative variations. So equal positive and equal negative variations are the average value of AC. That is equal to 0. So this is the representation of average value E naught sin omega t equal to 0, and also average value of current I naught sin omega t is equal to 0. So we can generally write the average value. Here it is I naught sin 2 omega t is equal to 0. E naught sin 3 omega t is equal to 0. In general, we can write average value of sin n omega t is equal to 0, and also average value of cos n omega t is equal to 0. So average value of AC, alternating quantity, for a complete cycle, that is always equal to 0. So here, so the average value of AC over a cycle equal to 0. So here the ordinary ammeters, okay, ordinary DC ammeter and DC voltmeter, they cannot measure. Okay, they cannot measure the alternating current or alternating voltage, because ordinary DC ammeter and DC voltmeter, they measures average value of the quantity, average value. If we put an AC signal to an ordinary DC voltmeter or a DC ammeter, it will show 0 reading, because average value of AC over a complete cycle is equal to 0. So remember that ordinary DC voltmeter and DC ammeter, they measures average value of the quantity. Okay, so here What about the average value of AC over a one half cycle? One half cycle. For full half cycle, that is equal to 0. For full cycle, that is equal to 0. For a half cycle, here for a positive half cycle, it is 2 E naught by pi. For a negative cycle, it is minus 2 E naught by pi. So 2 E naught by pi is equal to, that is 0.637 E naught. That is the average value for a positive cycle, and also the average value for negative cycle minus 0.637 E naught. So here also corresponding currents. For a positive cycle, average value of current is 2 I naught by pi. For the negative half, that is equal to minus 2 I naught by pi. These are the average values of AC for corresponding half cycles. Okay. So average 0 വരുമ്പോൾ, okay, average 0 വരുമ്പോൾ how to represent that quantity. So average value of a quantity 0, then we have to consider another term, that is root mean square value or effective value of AC, RMS value. RMS value உங்களுக்கு தெரியும், root mean square. Root mean square means உங்கள் அந்த quantity square பண்ணணும். Square பண்ணும்போது எப்படி வரும்? Negative square ஆகும்போது positive அங்க வரும். Then finally squaring, adding, take the square root. அந்த மெத்தட் ஃபாலோ பண்ணும்போது the value 0 கிடைக்காது. அப்போ உங்களுக்கு first case here AC average find பண்ணும்போது positive, negative direct add ஆகும், it becomes 0. So here now it is squaring. Squaring ஆகும்போது this becomes positive. Negative square பண்ணும்போது also it becomes positive. So then added and average, finally take the square root. Value whenever it is equal to 0. So that is the RMS value of AC. If average value 0 கிடைச்சால் we have to consider RMS value. So what is RMS value or effective value or virtual value of AC? அப்போ உங்களை all ordinary DC ammeter or voltmeter measure the average value. So for all AC instruments that measures root mean square value, RMS value of the quantity. So how to define RMS value? Root mean square value of AC is defined as that steady current which produces the same amount of heat in a conductor in a certain time interval as produced by AC in the same conductor during the same time period. That is the full cycle. So it is IRMS. RMS value of AC is also known as effective value or virtual value. So it is defined as the steady current which produces the same amount of heat in a conductor in a certain time interval as produced by AC in the same conductor during the same time interval. Okay. So RMS value of AC means that is the equivalent which value DC value. We represent the AC quantity in terms of DC. Okay. Suppose RMS value of AC that is equal to 20 volt means that 20 volt DC produces the same effect that is produced by the given quantity of AC. So we can represent the AC in terms of DC. So that is the RMS value of AC. So here, so the RMS value of AC, that is a mathematical method to find the RMS value. So here first we consider there is a resistor R. Resistor R உங்களுக்கு consider பண்ணணும். இந்த resistor உங்களுக்கு யாரு பாஸ் பண்ணணும்? Here it is an alternating quantity I naught sin omega t first உங்களுக்கு பாஸ் பண்ணணும். For the same resistance again consider பண்ணணும். இங்க யாரு பாஸ் பண்ணணும்? DC current பாஸ் பண்ணணும். These DC currents, these IRMS is known as RMS value of AC. This IRMS means IDC. Okay, so உங்களுக்கு here first இங்க heat measure பண்ணணும். Heat produced by யாரு measure பண்ணணும்? AC measure பண்ணணும் for the same resistance for the same time. So on the same resistance உங்களுக்கு யாரு பாஸ் பண்ணணும்? DC பாஸ் பண்ணணும் for the same resistance for the same time. Then இங்க heat find பண்ணணும். Heat produced by DC. So same amount of heat that is produced by AC, how much amount of DC current that is needed for the same heat production as done by the AC, that amount of DC current is known as RMS value of AC. RMS value of AC current. Okay, so here DC current உங்களுக்கு here it is 2 ampere current. Here உங்களுக்கு suppose 3 sin 50t, this is the AC current. இங்கே உங்கள் AC current 3 sin 50t இங்க பாஸ் பண்ணணும். இங்கே AC heat produce பண்ணும். Same heat கிடைക്കാൻ எவ்வளவு amount DC இங்க பாஸ் பண்ணி உங்களை 2 ampere பாஸ் பண்ணியால் we can say that 2 ampere is called the RMS value of AC current. Okay, so that's equivalent the DC current. Okay, so this is the mathematical method, root of integral 0 to t v square dt divided by 0 to dt PRMS v naught by root 2. So peak value கிடைச்சால் RMS value of AC mathematically it is V naught divided by root 2, and also for current I naught by root 2, that is equal to 0.707 I naught. These are the RMS value of AC. Okay, so here, so RMS value of AC, that is equal to peak value divided by root 2. അപ്പോൾ here household outlet, okay, suppose a voltmeter that is plugged into a household outlet, it reads a 230 volts. It reads a 230 volt means this 230 volt indicates which value? It's the RMS value of AC. This is the RMS value of AC that can be written as V naught by root 2, that is equal to 230 volt, and V naught is equal to 230 root 2. This is the peak value of AC. Peak value of AC. Okay. അപ്പോൾ generally AC 230 volt, AC 220 volt or 220 volt or 230 volt means this AC 220 volt means this is the RMS value. അപ്പോൾ direct 220 பார்த்தால் தெரியும் உங்களுக்கு 220 means it is not an AC. Okay, 220 means a constant value. Constant value means a DC value. So here this is the DC value for equivalent AC. Okay, so equivalent value of DC value of AC is known as RMS value of AC. So that is peak value divided by root 2, that is the RMS value of AC. And also we can find the RMS value by using mathematical method. So here this is the alternating signal. Alternating signal വരുമ്പോൾ here this value, peak value is V naught, it is also V naught. Okay, it is minus V naught. Here V RMS is equal to root of, here it is V naught square plus, here also minus V naught square. AC apply produce up, here there are 4 quadrants, 1, 2, 3, 4. Divided by 4, then we directly get it is V naught divided by root 2, that is the RMS value of AC also. For other intervals, that value becomes 0, only V naught and minus V naught the whole square divided by 4. And also there's a combinations I is equal to A sin omega t plus B cos omega t. For this combination, RMS value is equal to root of A square plus B square divided by 2 is the RMS value. Now I is equal to A plus B cos omega t. A plus B cos omega t. So here is the current, is the combination of the component, a DC component and an AC component. So here direct square panam plus for AC components B square divided by 2 write panniya podum. Okay, and also here I is equal to A sin omega t plus B cos omega t plus D sin omega t. So we can directly write root of A square by 2 plus B square by 2 plus is equal to D square by 2. So here I is equal to A plus B plus sin omega t. So it is equal to here direct DC term വരുമ്പോൾ A square plus B square plus AC term വരുമ്പോൾ here it is D. So now it is D square by 2. These are the shortcut method to find the RMS value. So this indicates it's a combination of DC and AC. Suppose the current consists of AC component and DC component വരുമ്പോൾ direct in the method உங்களுக்கு use பண்ணலாம் to find the RMS value of the quantity. So here, so AC measurements. Okay, how to measure AC? So AC that is measured by using AC voltmeter and AC ammeter. All AC instruments reads which value of the quantity? RMS value of the quantity. All DC instruments reads average value of the quantity. Okay, and all AC instruments based on the principle of heating effect of electric current. Here all DC instruments based on the principle of magnetic effect of electric current, magnetic effect. Okay, well RMS value find பண்ணும்போது ஸ்கொயரிங் வரணும். ஸ்கொயர் பண்ணியா மட்டும் நெகட்டிவ் become பாசிட்டிவ் ஆகும். இப்போ ஸ்கொயர் பண்ணும்போது which effect is a squaring effect? Heating effect. I square RT is the heat. இப்போ ஸ்கொயர் ஆகும்போது நெகட்டிவ் becomes positive. So that is the heating effect. RMS value, heating effect, average value and magnetic effect of electric current. Okay, so that is a comparison between AC and DC measurements. And also here in AC measurement the scales are non-linear scale. Here the scale that is non-linear. For DC instrument they are the linear scale. So now we move on to time taken. time taken by the alternating current to change from peak value to RMS value. So time taken by the AC to change from peak value to the RMS value. Here the peak value, we know that peak value I is equal to I naught sin omega t1. Peak value, that is I naught is equal to I naught sin omega t1. Omega t1 find pananam. Omega t1 is equal to pi by 2. T1 is equal to pi by 2 omega. Similarly, for RMS value, it is I naught divided by root 2. It is equal to I naught sin omega t2. Here t2 is equal to 3 pi by 4. So it is 3 pi by 4 omega. Take the difference between them. So the time that is equal to t by 8. Finally substituting, omega is equal to 2 pi by t. Okay, omega, the difference to find pananam. Finally omega 2 pi by t substitute பண்ணும்போது delta t0 t by 8. Time taken by the alternating current to change from peak value to the RMS value, that is equal to t divided by 8. Now we move on to the phasor and phasor diagrams. Okay, so how to represent that AC quantity? So AC quantity உங்களுக்கு simple represent பண்ண முடியும். So one of the method is the timing diagram. Timing diagram. Now this is an AC. Okay, timing diagram. With respect to time, we can represent the variation of the magnitudes. Suppose this is the voltage. Now there is another voltage like this. Okay, here. So now this is the another alternating signal. So here frequency that is slightly different. Now this representation is known as timing diagram. So this timing diagram that is very complicated to carry out the analysis of more than alternating quantities. அதுக்கு முன்னாடி உங்களுக்கு தெரியணும் what do you mean by phase of a physical quantity? Phase that generally used to compare two quantities. If two quantities are said to be same phase, they reaches their corresponding maximum and corresponding minimum at the same instant of time. Okay, here consider two alternating quantities. So that's one yellow quantity, then so red quantity. So we can see that both the quantities reaches their maximum and minimum and zero value at the same instant of time. So these two quantities are said to be same phase. Okay, so if two physical quantity compare பண்ணும்போது, okay, their maximum, minimum and zero values are not reaching at the same time. Now that quantity are said to be out of phase. That is said to be out of phase. So out of phase quantities represent பண்ணும்போது this one. Okay, here this is a sine signal. This is sine function. Now this one is the cosine function. So we can see that 0. Sine 0 is equal to 0. Cos 0 is equal to 1. Okay, that means sine 0 വരുம்போது sine that is minimum value, but cos 0 is equal to 1. So sine minimum വരുம்போது cosine அங்க maximum value வரும். That means cosine maximum, sine அந்த டைமில் minimum. So cosine முன்னாடி போகும், sine பின்னாடி வரும். That means cosine that is leading, sine that is lagging. That is cosine leads to sine. Cosine leads to sine by a phase angle. Cosine leads the sine by a phase angle of pi by 2 is the phase difference between sine and cos. Cosine function can lead out. Okay, suppose voltage leading, current lagging. That means voltage leading. Voltage leading means voltage maximum വരുம்போது current minimum വരും. Current leading, current maximum വരുம்போது voltage minimum വരും. So that is the voltage leading, current leading, lag lead. Okay, so remember two quantities are said to be same phase. They are reaching their corresponding maximum, minimum and zero at the same instant of time. Otherwise, they are said to be in out of phase quantities. Okay, so what is phasor and phasor diagram? So phasor diagram, it is a method to represent an alternating quantity. So phasors are generally rotating vectors. Okay, so phasors are rotating vectors that used to represent that quantity that varies sinusoidally with time. Now this is the phasor, the length of the phasor that is equal to the amplitude of the quantity. Here this is the location of the phasor after t seconds, the rotation of the phasor that is taken as anti-clockwise direction after t seconds. This is the angle swept by the phasor. Now the vertical component of the phasor that is given by v naught sin omega t is the vertical component of the phasor after t seconds. Okay, so this is the representation of an alternating quantity. So this indicates there is an alternating quantity of amplitude v naught that starting from this is the starting point at t equal to 0. Now this is the representation of alternating quantity. This is the corresponding timing diagram. This is v naught, this is minus v naught. So this is the timing diagram. But timing diagram paatha v naught minus v naught. Here this is the representation. So this is the representation of a phasor after t seconds. Suppose here there is another phasor. We can represent there is another phasor. This is also the representation of a phasor. This is a phasor also. This is the amplitude v naught. This phasor is at t equal to 0. Now t equal to 0, this is the location of the phasor. After t seconds, this is the location of the phasor. So here one complete rotation of the phasor that is corresponding to this 360 degree. Okay, so here consider the vertical projection, not the horizontal projection. Here this one is a cosine function, this one is a sine function. So this length, the length of the phasor, here this v naught sin omega t, this length indicates the v naught sin omega t. So here rotation of the phasor is treated as anti-clockwise with the speed omega equal to the angular frequency of the quantity varying sinusoidally with the time. The instantaneous value of AC is given by v naught sin omega t. So the length of the phasor is v naught, and it describes an angle theta is equal to omega t in time t, where omega is the angular frequency of the voltage of AC. So the vertical component of phasor v is equal to v naught sin omega t. Okay, so that is the phasor diagrams. Okay, so phasor is a rotating vector that varies sinusoidally with the time. So the instantaneous value of AC that is represented by the vector of length that is equal to the amplitude of the quantity and that rotates in anti-clockwise direction. So the vertical component of that vector that is equal to v naught sin omega t. So that method is used to represent alternating quantities. Suppose there are two alternating quantities with a different amplitude. Here there is a first alternating quantity is v1. This one is the second alternating quantity is v2. So from this we can represent that there are two alternating quantities. Remember that the rotation of the phasor that is treated as always anti-clockwise direction. Now this is omega t after t seconds. Here first phasor, what is the amplitude? v1. That is the first phasor. So if there is an alternating quantity, that amplitude is equal to v1, and also there is an alternating quantity. We can see that is lead with respect to the first quantity by an angle of phi. So it is v2. Evalo amplitude kammiyan. So that is a delay. v2 both are not in the same phase. So we can see that there are two alternating quantities of different amplitude and the second quantity leads the first one. So that is the conclusion. So we can represent by using this. Now this is another quantity. Now this is leading. This is v2. Okay, so because rotation of the phasor that is treated as anti-clockwise direction. Okay, so this concept generally used to solve complex AC circuits. Okay, in syllabus only 1 or 2 AC signals mattum varum. Complex circuit varumbodhu more than AC signals varumbodhu very difficult to solve by using the timing diagram. Okay, ungalku phasor diagram method use panni romba easy ah solve panna mudiyum. Okay, so that is the idea of phasor. But just ungala phasor or vector maadhiri rotate aava. Okay, appadi mattum think panniya podum, and we can use the all the laws of vector addition to manipulate these phasors. Okay, so here we do leading. So v1 that is lagging. Suppose there is another phasor diagram. What's the meaning? Here it is v1, it is v2. What's the meaning of this? Here there are two phasors, different amplitude. First alternating quantity amplitude is v2, another one is v1. Both are having the different amplitude but Both are at the same instant of time. That means both these phases, both these alternating quantities are in the same phase. That is the meaning of this phasor diagram. Okay, so move on to the AC circuit. So AC voltage applied to a pure resistive circuit. Pure resistive circuit AC voltage apply பண்ணும்போது here V is equal V naught sin omega t. So current I is equal to I naught sin omega t. We know that current I is equal to V naught sin omega t divided by R. That is equal to I naught sin omega t is current. That means voltage and current are in the same phase. Voltage maximum varumbodhu current also maximum, voltage minimum varumbodhu current also minimum. So the voltage and the current are in the same phase in a circuit containing resistance only. So both are in phase with each other, and average power P is equal to Vrms into Irms is the average power. That is also is equal to average power is Irms square by R. That is equal to Vrms square divided by R. That is the average power dissipated in a pure AC circuit. Power that is dissipated in the form of heat. Okay, so that is AC applied to a resistor. Move on to the phasor and timing diagram. So we can see that for a timing diagram here, this is the representation of a voltage phasor. This is the voltage phasor. This one is the current phasor. Both reaches the maximum and minimum at the same instant of time. Okay, so there is no phase difference between the voltage and current. So move on to the phasor diagram. Phasor diagram varumbodhu this one is the voltage phasor V naught. This one is the current phasor I naught. Okay, both are having the different amplitude, but both are in the same phase. Both reaches the correct position at the correct time. No leading, no lagging. So that is the timing and phasor diagram of AC circuits that containing only pure resistor. So here in this case, so what is the average power? See, average power is equal to Irms square R. Irms is I naught divided by root 2. The whole square into R, that is equal to I naught square R divided by 2. What is the instantaneous power? Instantaneous power is instantaneous current into R. That is equal to I naught square sin square omega t into R. So what is the ratio of average power to instantaneous power? Ratio of average power to instantaneous power find பண்ணும்போது here it is R get cancelled, I naught square omega cancel out. So here P average by P instantaneous, that is equal to 1 divided by 2 sin square omega t. The ratio of average power to instantaneous power dissipated in the AC circuit containing pure resistance only. So move to the next one, that is AC supplied to a pure inductive circuit, pure inductor. So voltage V is equal to V naught sin omega t, the current I naught is equal to sin omega t minus pi by 2. So inductive circuit varumbodhu, for a pure inductive circuit that is connected with an alternating source. So we know that according to Faraday, an EMF is induced. EMF அங்கே induce ஆகும். So EMF is induced, அதுக்கப்புறம் current அங்கே induce ஆகும். So initially EMF is induced, now அதுக்கப்புறம் only current அங்கே induce ஆகும். That means EMF initially induced, then current. So EMF leading, current அங்கே lag ஆகும். So that is current lag behind the voltage by a phase angle of pi by 2. So here current also is equal to minus I naught cos omega t. Sin omega t minus pi by 2 is equal to minus cos omega t. So average power consumed in a pure inductive circuit is equal to 0. And these are the voltage and phasor diagrams. So move on to the phasor diagram. You see the voltage phasor after t seconds. Now it is omega t. So here voltage leading, current பின்னாடி வரணும். Current phasor, that is amplitude கம்மியாகும். So here there is a phase difference between them of 90 degree. So the voltage leading, that is current lagging in a pure inductive circuit. In the phasor diagram, voltage முன்னாடி வரணும், current பின்னாடி வரணும். So the rotation of the phasor is in the anti-clockwise sense. Here these are the corresponding timing diagram. This is the voltage, this one is the current. Voltage in terms of sine function, current in terms of minus cosine function. So current that is minus I naught cos omega t is variation. Okay, so how to find the current So current I is equal to V divided by opposition. Current I is equal to V divided by that opposition, that is XL. That XL is known as the inductive reactance. In the previous case, current find money V divided by R, similar to what? R is the resistance. Okay, here there's a pure inductor that offers only reactance, resistance of the pure inductor. Resistance of the pure inductor is equal to 0. The pure inductor that offers only reactance. So reactance or inductive reactance is the effective opposition offered by the inductor to the flow of alternating current in the circuit. So XL is equal to L omega, that is equal to 2 pi FL, that is inductive reactance directly proportional to the frequency. Inductive reactance directly proportional to the frequency. Here for DC we know that frequency equal to 0, XL equal to 0. That means DC current that is easily flows through our inductor. For AC we know that frequency that is finite, so inductor offers finite opposition to the flow of AC. So reactance, it is not a resistance. Okay, reactance is the opposition offered by the inductor to the flow of alternating current, and the reactance that arises only in AC circuit, but resistance can found in both AC and DC circuits. And also AC is supplied to a pure capacitor. V equal to V naught sin omega t, I is equal to I naught sin omega t plus pi by 2. This current is known as conduction current or displacement current through the capacitor plates. Okay, conduction current or displacement current. So here in case of a capacitor that is connected to an alternating source, we can see that capacitor that is initially that is charged, now it is plus Q and it is minus Q. Charge there is an electric field that is created. Electric potential difference setup. So initially charge flow charge potential difference. Initially flow charge. Initially charge flow means initially there is a current. Potential difference develop. So we can conclude that here current that is leading. Initially current develop. So current leads the EMF by a phase angle of pi by 2 in case of pure capacitor and also ideal conditions. Okay, so here current I naught sin omega t plus pi by 2, current in terms of cosine function I naught cos omega t. Okay, so here for a capacitor circuit, it also offers here pure capacitor also offers reactance. Resistance offered by the capacitor is equal to 0. So move on to the capacitive reactance. So just to familiarize the phasor diagram. Here this is the voltage phasor that rotates in anti-clockwise direction. After t seconds, this is the location. We can see that current leads the voltage. Current munnadi podam, that phase angle is 90 degree. Move on to the timing diagrams. This is the voltage. This one is the voltage V naught sin omega t. Current cosine function I naught. This is the current phasor. Okay, this is the current phasor. I naught cos omega t. This is the voltage phasor V naught sin omega t. Here the current leads the voltage by a phase difference of pi by 2. Capacitive reactance. So capacitive reactance is the effective opposition offered by a capacitor to the flow of alternating current. Capacitor reactance equal to 1 by C omega, that is equal to 1 by 2 pi FL. For DC, frequency equal to 0. Capacitive reactance is infinity. That means capacitor offers infinite opposition to the flow of DC. And for AC, F is finite, X is smaller value. So AC current that easily flows through a capacitor. So in this pure capacitor or a pure inductor, okay, only pure term varumbodhu only reactance mattum varum, no resistance. Okay, so reactance arises only in AC circuit with a pure reactance, no power dissipation. So we can see that for a pure AC resistive circuit, average power that is not equal to 0. For a pure capacitive and pure inductive circuit, average power consumed equal to 0. Okay, so for capacitor and pure inductor, power consumed equal to 0. So power consumed only in the presence of our resistance only. Resistance vanna mattum ange power anga dissipate agum, adukapram power dissipation kediyadhu. So pure inductor and pure capacitor, no loss of power because there is no resistance. Okay, so here there is a comparison between resistance and reactance. Resistance can be found in both AC and DC circuits. Only in AC circuit the term reactance arises, and also the resistance does not depends on frequency of AC, but reactance depends on frequency of AC. Okay, for inductive reactance directly proportional to frequency, and the capacitive reactance inversely proportional to frequency. Frequency increase panniyalum decrease panniyalum resistance does not change. Okay, suppose an AC circuit that is connected with a resistor. Now the frequency of AC increases or decreases, whatever it is, the resistance remains constant. Now the circuit consists of an inductor or a capacitor. If the supply voltage increases, the frequency of the supply changes. What happened? Reactance changes, but resistance remains constant. And another important point is resistance causes the generation of heat in a component, but no heat production in a circuit with a pure reactance. Pure reactance വരുമ്പോൾ heat production கிடையாது. And also the capacitive reactance, we know that X is equal to 1 by C omega. If the capacitor is inserted with a dielectric material insert பண்ணும்போது capacitance increase ஆகும், but capacitive reactance decrease ஆகும், current through the circuit increases. So that is R, L and C. Now there is a combination of AC circuit, that is LCR circuit. Okay, LCR series circuit, it contains L, C and R. They are connected in series with an alternating source of V is equal to V naught sin omega t. This is a series circuit, so the current through the all the circuit elements are same. That is I is the current through the all the circuit elements. This I is known as the RMS value of current. RMS value of current through all the circuit elements, and VL is the voltage across inductor, means RMS value of voltage across inductor, and VC is the RMS value of voltage across the capacitor, and VR is the RMS value of voltage across the resistor. Okay, so move on to the individual phasor diagrams. For inductor വരുമ്പോൾ here this is the current I, this is the voltage VL, so voltage leads the current by a phase angle of pi by 2. Now for a capacitor, in case of capacitor വരുമ്പോൾ this is the current I, now this is the voltage VC, so here current leads the voltage by a phase angle of pi by 2. Now this is the resistance, now this is the current I, this is the voltage VR, all are in the same phase. Now combining all these vectors, phase sides ungal combine பண்ணும்போது here it is VL மேல வரும், here VL மேல வரும், here VC எங்க போகும், VC கீழ போகும், here now VC இங்க வரும், VC கீழ போகும். Now this is VR and I. So here we assume that here we can see that VL and VC are in opposite direction. So applying the law of vectors, here we assume that suppose VL greater than VC. Now the resultant phasor diagram വരുമ്പോൾ now this is the resultant phasor diagram. VL minus VC is in the upward direction. This is the current. Now this is the resultant voltage makes an angle phi with the current. So V is the resultant voltage across LCR. Okay, so V is the RMS value of voltage. So how to find the resultant voltage? V, here VL minus VC and VR are perpendicular. Resultant voltage across LCR circuit is given by V is equal to root of VR square plus VL minus VC the whole square. So here VR square plus VL minus VC the whole square. How to write VR? Voltage across the resistance, RMS value of voltage across the resistance I into R, RMS value of voltage across inductor VL is equal to I into XL, RMS value of voltage across the capacitor I into XC. By substituting VL, VR and these values, finally you get Z is equal to, there's a term V by I, that is equal to root of R square plus XL minus XC the whole square. So that is known as the impedance of the circuit. Impedance. So what is impedance? It is the net opposition offered by the LCR circuit to the flow of alternating current is known as impedance. What is impedance? Z is equal to root of R square plus XL minus XC the whole square. So resistance that is the opposition. Reactance also the opposition. Impedance means the effect of resistance and reactance. So that is impedance. Generally current is equal to net voltage by resistance. For AC circuits, net voltage by impedance. So we can write here the current. What is the current? Current I is equal to V by R is the current. Okay, V by R is the current. So here I, that stands for RMS value of the current. V is the RMS value of voltage. Okay, here R More technically, that R that is replaced with Z in AC circuit. Okay, so current is equal to RMS value of voltage by impedance of the circuit. Okay, so here generally in DC circuits, so what is the resistance? Resistance is equal to VDC by IDC. That is the resistance. Direct voltage divided by direct current. The resistance for AC circuit, remember that Z is equal to V by I. That V means VRMS divided by R. VRMS by IRMS, that is Z. Okay, Z is the impedance of the circuit. So nothing but it is the net effect of reactance and resistance. Now what is phi? Here phi is the angle between net voltage and current in an LCR series circuit. For pure inductive circuit and pure capacitive circuit, voltage and current, the angle between voltage and current, that is pi by 2. For a pure FC circuit, that is 0. For LCR circuit, that angle is phi. That phi tan phi is equal to XL minus XC divided by R. Tan phi is the angle between resultant voltage and current in an LCR series circuit. Tan phi is equal to XL minus XC divided by R. So here tan phi is the XL minus XC divided by R. It is also equal to VL minus VC divided by R. So here V is equal to V naught sin omega t. That's the voltage applied across an LCR series circuit. Current I is equal to I naught sin omega t plus or minus phi, because if XL equal to XC, substitute here XL equal to XC means tan phi is equal to tan phi equal to 0 degree. What is phi? Angle between voltage and current. Phi equal to 0 degree. That means there is no phase difference between voltage and current. Now that LCR circuit is act as pure resistive circuit. And if XL greater than XC, phi becomes positive. Phi positive voltage leads the current. That means that LCR circuit behaves as inductive dominated, not pure inductor. Pure inductor phi pi by 2. Here VL greater than VC means here voltage leading, current lagging. Now it is inductive dominated circuit. If XL less than XC means capacity dominated. Now what happens? XL less than XC the capacity reactance this phi becomes negative. That means voltage that is lagging, current leading. So now the circuit behaves as capacity dominated. So the LCR circuit that shows three types of behavior depending upon the values of XL, XC and R. Okay, so these are pure resistive, inductive dominated and capacitive dominated circuits. So voltage that is V naught sin omega t, current that can be written as I naught sin omega t plus or minus phi. So how to write for a pure resistive circuit? Current that becomes I naught sin omega t is representation. For inductive dominated circuit current I naught sin omega t phi. That for inductive dominator. Capacity dominated the current angle lead by a phase angle of phi. This angle are not pi by 2. Pure elements that becomes pi by 2. So that is the LCR series circuit. So now there is a term that is electrical resonance. So electrical resonance is said to take place in a series LCR circuit. The circuit allows maximum current for a given frequency of alternating supply for which capacity reactance becomes equal to the inductive reactance. So we know that the relation between inductive reactance and frequency, inductive reactance and capacitive reactance, inductive reactance directly proportional to frequency, capacitive reactance inversely proportional to frequency. At a particular point, both the reactants are equal. XL is equal to XC. XL equal to XC, we know that impedance of the circuit Z is equal to root of R square plus XL minus XC the whole square. XL equal to XC, that becomes cancelled. So LCR circuit acts as pure resistance, pure resistive circuit. Current is equal to V by Z, V divided by R. So at a resonance, current through the LCR circuit is maximum and impedance of the circuit is minimum. It acts as a pure resistive circuit. So resonance occurs at a particular frequency known as the resonant frequency. At resonance, current maximum, so impedance is minimum. The frequency of resonance is given by 1 by 2 pi root LC. Maximum current is V by R. Minimum is the impedance, minimum impedance that is equal to resistance. Okay, so At resonance, it acts as a pure resistive circuit. So move on to the resonance curve. So current I is equal to R. I is equal to V divided by R is the current. So here resistance increase ஆகும்போது here it is R3, R2, R1 resistance increase ஆகும்போது that maximum current அங்க decrease ஆகும். Resistance increases, current go on decreases. This is the resonant frequency omega naught. Omega naught is 1 by root of LC. Now variation with the impedance with the frequency of alternating voltage. Here impedance that is minimum, that is equal to pure resistive at a resonant frequency. At a resonant frequency, LCR circuit behaves as pure resistive circuit. Current and voltage are in the same phase. So at omega equal to omega naught, LCR circuit is pure resistive. So omega less than omega naught means below the resonant frequency. Frequency கம்மியாகும்போது we know that frequency கம்மியாகும்போது capacity reactance அங்க increase ஆகும். So XC அங்க increase ஆகும். Here frequency கம்மியாகும்போது XC greater than XL, that means LCR circuit is capacitive dominated circuit. Capacitive dominated circuit. And if omega greater than omega naught, above the resonant frequency மேலே போகும்போது with reactance அதிகம், inductive reactance அதிகம் வரும் compared to the capacitive reactance. Now the LCR circuit is behaves as inductive dominated circuit. Okay, so at resonant frequency pure resistive, below the resonance frequency capacity, above the resonant frequency, that is LCR circuit acts as an inductive circuit. Pure inductive கிடையாது, inductive dominated circuit. அப்போ உங்களுக்கு here generally there is an LCR circuit arrangement വരുമ്പോൾ how to find the potential difference between here A and B கேட்டால, now it is connected to an alternating supply. Potential difference between A and B here VA minus VB உங்களுக்கு find பண்ணும்போது தெரியணும். Here there is a resistance, capacitance, there is a resistance, RC circuit. So here voltage across the resistor and the capacitor உங்களுக்கு consider பண்ணும்போது they are mutually perpendicular. Here we can write it is equal to VR square plus VC square, that is the result. Okay, உங்களுக்கு potential difference between RLC direct find பண்ணா RLC root of R square plus XL minus XC the whole square. So that is the VR square plus VL minus VC the whole square between A and B. உங்களுக்கு any two elements கேட்டால், so what is the potential difference between C and A? Okay, C and A because across inductor, C and D கேட்டால் VD minus VC, VD minus VC வரும்போது here it is IXC, this is IXL. So inductor and capacitor consider பண்ணும்போது they are out of phase, 180 degree அங்க வரும். So between inductor and capacitor கேட்டால் IXL minus IXC or IXC minus IXL find பண்ணணும். Okay, so அப்போ உங்களை normal Kirchhoff law apply பண்ணி உங்களை ரைட் பண்ண கூடாது, VA minus VB. Okay, here it is. Okay, phasor method apply பண்ணணும். angle between them எல்லாமே find பண்ணி உங்களுக்கு final result find பண்ணணும். Okay, so that is the resonance. Now move on to the quality factor. Quality factor of LCR circuit is defined as the voltage divided across inductor or a voltage at the capacitor at resonance to the voltage applied. So sharpness of the resonance is determined by the quality factor of the circuit. So quality factor is nothing but the ratio of voltage across inductor or capacitor at resonance to the applied voltage or voltage across the resistor. Okay, at resonance വരുമ്പോൾ applied voltage is same as that of the voltage across the resistance. So this is the definition. Quality factor, it is voltage across inductor or capacitor divided by applied voltage. IXL by IR, applied voltage is I into R. IXC divided by IR, XL by R or XC by R. XL is L omega 0 by R or 1 by C omega 0 by R. Substituting omega naught is equal to 1 by root of LC. You get the quality factor is equal to 1 by R into root of L by C. That quality factor that determines the sharpness of the resonance. Sharpness of the resonance, that means here this one, you see the resonance curve, this is the another resonance curve. This means this resonance curve is more sharp. This is more sharp. This one is less sharp. More sharp means the circuit that is more quality factor. This is more quality factor. This one is less quality factor. Okay, so more sharp, more quality, less sharp, less quality. So it determines the quality factor on the sharpness of the resonance. So here what the relation between quality factor and bandwidth. Quality factor is equal to resonant frequency divided by bandwidth. So what do you mean by bandwidth of the circuit? Okay, so how to find the bandwidth? Bandwidth means here this is the resonance curve. Here this is the maximum current I naught. Here we select two frequencies corresponding to the current in the circuit drops to the 1/√2 times the maximum value of current. These two frequencies are omega 1 and omega 2. Now this is the resonant frequency omega naught. Okay, so these omega 1 and omega 2 are known as half power frequencies because these frequencies are corresponding to the power dissipated in the circuit is the half of the maximum power or current drops to 1/√2 times the maximum current. So we select two frequencies omega 1 and omega 2. The difference omega 2 minus omega 1 is known as bandwidth of the circuit. We can write omega 2 is equal to omega naught plus delta omega. Omega 1 is equal to omega naught minus delta omega. So take the difference, you get 2 delta omega. And also this delta omega is equal to R by 12. Bandwidth is equal to, that is R divided by L, that is the bandwidth, that is 2 times delta omega is bandwidth. Multiply பண்ணும்போது R by L. So for the relation, quality factor is equal to resonant frequency divided by bandwidth. Quality factor is resonant frequency by bandwidth. So these are the two resonance curve. So quality factor is equal to resonant frequency by bandwidth. Bandwidth adhigam varumbodhu more bandwidth. So this is the more bandwidth varumbodhu quality factor kammiyavum. So the circuit becomes less sharp. In the red diagram paathaal bandwidth kammiyavumbodu quality factor adhigam varum. Now it is more sharp means the circuit is more selective. So the quality factor also indicates the selectivity of the circuit. Here this one is more selective. This curve that is less selective. Less selective means very difficult to select the resonant frequency. Here the circuit is close to resonance for a large range of frequency. Here there is a sharp peak corresponding to the resonant frequency. So we can select the resonant frequency in communication systems. So here for a more sharp, more quality, that means more selective. We can select the resonant frequency. So that's the relation between quality factor, resonant frequency and bandwidth of the circuit. So here in RLC circuits, so RLC circuit உங்களுக்கு consider பண்ணும்போது or LCR circuit that is connected to an alternating supply. So here impedance எல்லாமே உங்களுக்கு find பண்ணி Z, voltage, phase related எல்லாமே find பண்ணியாச்சு. So உங்களுக்கு questions வரும்போது suppose inductor அங்க remove பண்ணும். Now it is only RC circuit. RC circuit வரும்போது no issue. Z find பண்ணனும் உங்களுக்கு just அந்த inductance remove பண்ணியா போதும். R square plus XL square and also phasor. Okay, here it is tan phi is equal to R. Here it is XC divided by R. Direct find பண்ண XC divided by R. அந்த மாதிரி அந்த மெத்தட் யூஸ் பண்ணலாம். Suppose உங்களுக்கு இண்டக்டர், கெபாசிட்டர் and resistor, instead of that here it is capacitor remove பண்ணும்போது you get inductor and resistance. It is a LR circuiting வரும். LR circuit வரும்போது here we can find Z is equal to root of R square plus XL square உங்களுக்கு find பண்ணணும். Okay, so here it is XC square, sorry it is XC square, it is XL square இங்க வரும். Phi find பண்ணா phi is equal to R tan inverse, it is XC divided by R. Okay, இப்போ tan inverse XC by R யூஸ் பண்ணிய போதும். உங்களுக்கு டைரக்ட்டா instead of RLC circuit R remove பண்ணா L remove பண்ணா RC, RLC, LC அந்த மாதிரி செப்பரேட்டா क्वेश्चन கேக்கும். உங்களை அந்த phasor diagram யூஸ் பண்ணி ஃபைண்ட் பண்ணியா போதும். Okay, now move on to the average power of AC circuit. Average power P is equal to this one Vrms, Irms, cos phi is the average power dissipated in any AC circuit. These Vrms, Irms, cos phi is called true power dissipated. True power means உங்களை by using watt meter உங்களை measure பண்ணியால Vrms வேணா Irms and also we know the angle between the voltage and current. That is a true power and Vrms into Irms is called apparent power. Apparent power means generally it is a measured power. இப்போ உங்களுக்கு generally ஒரு AC circuit கன்சிடர் பண்ணும்போது Vrms, Irms, voltmeter reading, ammeter reading யூஸ் பண்ணி மல்டிப்ளை பண்ணியால true power கிடைக்குது. Okay, To get the true power, we need cos phi. So that is, it is true power. This VRMS, IRMS is the apparent power. Measure பண்ணும்போது VRMS into IRMS find பண்ணி, that is not a true power. For a DC circuit உங்களுக்கு direct VRMS, IRMS voltage current measure பண்ணனும், multiply பண்ணியால் உங்களுக்கு power கிடைக்கும். But AC circuit direct அந்த VRMS or voltage current, that is not equal to a power, that is the apparent power. This is the true power. We know the angle, so by using wattmeter we can measure the power factor. So cos phi is called a power factor of the circuit, power factor. So using that equation we get a P is equal to VRMS IRMS cos phi. By using this equation for a pure resistive circuit, phi equal to 0 degree, P equal to VRMS IRMS. Pure inductor and pure capacitive circuit, we get a phi is equal to pi by 2, then we can directly write P equal to 0. There is no power dissipation in case of pure inductor and pure capacitor. Phi எங்க pi by 2 வரும், pure resistive உங்களுக்கு direct phi 0 substitute பண்ணலாம். Okay, so that is power dissipated, and also the average power P is equal to VRMS IRMS cos phi, and also it can be written as VRMS by Z the whole square into R. This is also the power dissipated in AC circuit, VRMS by Z the whole square into R. In the equation உங்களுக்கு யூஸ் பண்ண no problem. So wattless current and watt full current. Okay, so here wattless current and watt full current உங்களுக்கு consider பண்ணும்போது, here the power dissipated in an AC circuit is VRMS IRMS cos phi. So what is cos phi? Cos phi is the angle between VRMS and IRMS. So phi. Okay, so angle between VRMS and IRMS. Angle between the VRMS and IRMS, that is the phi. So power is equal to VRMS IRMS cos phi. So we can resolve. Okay, we can resolve the components into two directions. So here this is the VRMS, this one is the IRMS. Okay, to resolve பண்ணும்போது there are two components. So one component, so here it is VRMS, this is IRMS, this is phi. So we can define two power in these circuits. There are two power, wattless power and watt full power. So what is wattless power, what is watt full power? So here IRMS, VRMS, here we resolve this. This is IRMS cos phi in the direction of VRMS. Okay, now this is IRMS sin phi perpendicular to the direction of VRMS. Okay, so VRMS IRMS cos phi. So here VRMS IRMS cos phi, same direction. This IRMS sin phi perpendicular direction. So here the angle between them is 0. Here there is a power VRMS IRMS cos phi. This is known as the, okay, so this is known as IRMS cos phi, that contributes the power in the circuit. IRMS cos phi is known as watt full power, and these components IRMS sin phi and VRMS 90 degree substitute பண்ணும்போது that becomes 0. Then you get IRMS sin phi does not contribute any power in the circuit. So there are two currents. IRMS cos phi is known as watt full current, IRMS sin phi is known as wattless current. Okay, so for a pure resistive circuit, for a pure resistive circuit, what is phi? Phi equal to 0. Phi 0 substitute பண்ணும்போது we get IRMS. Now which current exists? Here it is watt full current exists. Okay, phi இங்க 0 பண்ணியாலே it becomes 0. Phi இங்க 0 substitute பண்ணும்போது இங்க 0 ஆயிடும். That means for a pure resistive circuit only watt full current exists, no wattless current. For pure inductive circuit, inductor வரும்போது phi pi by 2 ஆയിരിக்கும். Phi pi by 2 இங்க substitute பண்ணியாலே இந்த value becomes 0. So there is no watt full current. So here phi pi by 2 substitute பண்ணியாலே இங்க யாரு கிடைக்கும்? IRMS கிடைக்கும். That IRMS is known as wattless current. உங்களுக்கு just அந்த vector diagram consider பண்ண வேண்டாம். Just we resolve the IRMS along two directions. One is along VRMS and it is perpendicular to the VRMS. So there are two components. IRMS cos phi is watt full current, IRMS sin phi is wattless current. Okay, so here we know that in case of a RC circuit, here it is RC circuit, voltage current relation. Okay, phasor diagram பார்த்தாலே here யாரு current அங்க lead ஆகும், voltage அங்க lag ஆகும். Okay, so current leading, voltage is okay lagging. So for a capacitor வரும்போது current அங்க lead ஆகும். So this is the current, so this is the voltage. So current அங்க lead ஆகும், voltage அங்க lag. This is phi. So here what is the time lag between Vmax and Imax? The time lag between Vmax and Imax, generally question delta T. Okay, time lag between Vmax and Imax is equal to, that is equal to, here V is equal to V naught sin omega t. இப்போ எவ்வளோ டைமில் வோல்டேஜ் எங்கே மேக்ஸிமம் வரும், தட் இஸ் வி நோ தட் பை பை 2 ஒமேகா. சிமிலர்லி உங்களை கரண்ட் ஃபைன் பண்ணும்போது கரண்ட் இட் இஸ் லீடிங் I naught sin omega t plus. Again we have to find T2 உங்களுக்கு ஃபைன் பண்ணணும். Then T2 minus T2 of T1 ஃபைன் பண்ணணும். உங்களுக்கு delta T is equal to you get that is equal to pi by omega கிடைக்கும். So that is the time lag between 5 by omega, not 5 divided by omega. Delta T is equal to 5 divided by omega. So that is the time lag between Vmax and Imax in both RC circuit and also RL circuit. Then phi உங்களுக்கு corresponding find பண்ணியா போதும். For RC circuit phi is equal to tan inverse XC by R substitute. Okay, so there is a time lag between Vmax and Imax. In an RC and RL circuit is delta T equal to 5 by omega. Remember that in the method use பண்ணி உங்களுக்கு answer find பண்ணலாம். Okay, now move on to the transformer. So transformer உங்களுக்கு தெரியும், it works on the principle of mutual induction. These are the terms. Number of turns in primary, secondary, applied voltage in primary, secondary, induced EMF in primary, secondary, flux in primary and secondary, primary current. Secondary current for an ideal transformer, there is no loss of power. Okay, primary power equal to secondary power. There are two types of transformer. Step up transformer, to step up increases the voltage and decreases the current. So here Vs greater than Vp, these are the properties. Ns greater than Np, Es, Ep, Is less than Ip, and K is known as a transformation ratio, K greater than 1. So for a step down transformer, so here it step down transformer വരുമ്പോൾ it decreases the voltage and increases the current. Okay, that is missing. Okay, so it increases the current and decreases the voltage. So here for a step down transformer வரும்போது உங்களுக்கு எப்படி ரைட் பண்ணா, here it is Vs that is less than Vp, here it is Ns less than Np. இது மட்டும் அங்க சேஞ்ச் ஆகும். Okay, so here step down வரும்போது voltage அங்க step down ஆகும், current அங்க step up ஆகும், opposite வரும். So that is transformer. But transformer வரும்போது உங்களுக்கு क्वेश्चंस இப்படி தான் வரும், voltage across primary by voltage secondary, number of turns in primary by number of turns in secondary. So here that is equal to Is divided by Ip. இந்த equations யூஸ் பண்ணியா போதும். Okay, direct questions கேக்கும் efficiency of the transformer, that is output power divided by input power is efficiency. உங்களுக்கு direct questions வரும் by using these formulas only. Okay, so this is all about alternating current. அப்ப உங்களுக்கு கரெக்ட்டா the equations கரெக்ட்டா உங்களுக்கு மனப்பாடம் பண்ணியே போதும். இந்த மாதிரி ட்விஸ்டட் கொஸ்டின்ஸ் இந்த மாதிரி வராது. இப்போ ஏசி கொஸ்டின்ஸ் உங்களை ப்ரீவியஸ் கொஸ்டின் பேப்பர் பார்த்தால் எல்லாமே டைரெக்டாக கொஸ்டின்ஸ். இக்குவேஷன்ஸ் ஃபுல்லாக மனப்பாடம் பண்ணுங்க. விச் சிச்சுவேஷன் விச் இக்குவேஷன் யூஸ் பண்ணணும் அது மட்டும் உங்களை ரிமெம்பர் பண்ணணும். ஓகே, தட் இஸ் ஆல் அபவுட் ஏசி. தேங்க்யூ.